Welcome to our deep dive into one of Microsoft's cutting-edge AI models, KOSMOS 2. Developed by the brilliant minds at Microsoft Research, KOSMOS 2 is part of the exciting world of Multimodal Large Language Models, or MLLMs. In the realm of AI, multimodal refers to the ability of models like KOSMOS 2 to work with different types of data, such as text and images. Large language models means that it excels at understanding and generating human-like language. Microsoft's KOSMOS 2 acts like a super-intelligent AI assistant, capable of linking your words into visual data. KOSMOS 2 can associate complex sentences to corresponding scenarios in images, thanks to its groundbreaking capabilities. It's not just about recognizing the individual words, but understanding the whole scene in a visual context. Consider you're talking about a sunset over the ocean. Microsoft's KOSMOS 2 doesn't just recognize the words sunset, ocean, or over. It can also visualize the scenario. This AI model has been trained to understand the bounding boxes concept in computer vision. This means it can determine the position and size of the sunset and ocean in a hypothetical image. So, KOSMOS 2 would comprehend that sunset typically implies the sun low in the sky, usually towards the top middle or top portion of an image, and the ocean is typically depicted as a large body of water, typically occupying the lower part of the image. Furthermore, it understands over to mean that the sunset is located above the ocean in the image. So, using its knowledge from the GRIT dataset, KOSMOS can visualize an image where the sun is setting over the horizon of the ocean. A unique feature of Microsoft's KOSMOS 2 is its ability to convert object descriptions into location tokens using a markdown format. It's like building a virtual bridge between your words and the corresponding object in an image. This incredible feature allows KOSMOS 2 to link text to the visual world, essentially blending the worlds of language and visuals. You might be wondering how Microsoft's KOSMOS 2 learns to do this. It's trained with a substantial dataset called GRIT, short for Grounded Image Text Pairs. This dataset is packed with pairs of images and text that correspond to each other, enabling the model to learn the link between visual and textual information. In addition to understanding the connections between text and images, Microsoft's KOSMOS 2 handles tasks you'd expect from multimodal large language models. This includes understanding various data types, following instructions, and learning new things based on its previous knowledge. What makes KOSMOS 2 stand out is its grounding abilities integrated into practical applications, empowering AI to understand and interact with the world like humans. We'll also be discussing the ethical considerations taken by Microsoft in the development and use of KOSMOS 2 later on in the video, so be sure to watch till the end. Microsoft put KOSMOS 2 through rigorous tests in understanding referring expressions, generating its own referring expressions, and performing perception language tasks. Additionally, it executed standard language understanding and generation tasks, proving the robust capabilities of this AI model. In essence, Microsoft's KOSMOS 2 is a monumental stride towards what we call embodiment AI. This form of AI is designed to comprehend and interact with the world, much like humans do. KOSMOS 2 exemplifies the unification of language understanding, multimodal perception, which means it can perceive and process various types of data, task execution, and world modeling, a fancy term for creating digital representations of the world. To put it simply, Microsoft's KOSMOS 2 is acting as a bridge, closing the gap between language, visuals, action, and understanding. This breakthrough paves the way towards our pursuit of developing artificial general intelligence, or AGI, an AI capable of performing any intellectual task a human can. For those of you interested in digging deeper into KOSMOS 2, the dataset used in this training, and its pre-trained models, check out the GitHub repo linked in the description below. There, you can explore more about this remarkable technology from Microsoft. Multimodal Large Language Models, or MLLM for short, have made some significant strides in recent years. These power-packed AI models are making waves in the AI field, acting as both versatile tools that can handle tasks involving language, vision, and the combination of both. They have the power to understand a variety of data types, such as text, images, and audio. Furthermore, they can creatively generate responses in free-form text, even with little or no previous examples. This capability is known as zero-shot and few-shot settings. Now, the expert team at Microsoft Research has added a new capability to MLLMs, the power to ground text with images. This feature enhances the human-AI interaction, making it easier to handle tasks that involve both vision and language. Imagine this: you're referring to a specific object in a picture. Without the grounding ability, you need to meticulously describe the object for the AI to understand. But Microsoft's KOSMOS 2, with its grounding superpower, changes the game. You can directly point to the object in the image, and KOSMOS 2 will comprehend that specific region. This magic happens because KOSMOS 2 understands spatial locations within images. Microsoft's KOSMOS 2 also responds with visual elements, such as bounding boxes, making it easier to understand referring expressions. It resolves any ambiguity in text-only responses by linking text responses to specific image regions, delivering accurate, insightful, and comprehensive answers. But how did Microsoft make this happen? KOSMOS 2 is an upgraded version of KOSMOS 1, based on the efficient transformer architecture, known for its effectiveness in language tasks. To train KOSMOS 2, they used a large dataset of image-text pairs, merging it with a multimodal dataset from KOSMOS 1. The image-text pairs were compiled from two major datasets, Lion 2B and Koyo 700M. Microsoft developed a method to extract text spans from the image captions and link them to the objects or regions in the image. The spatial locations of these objects were translated into tokens and linked with the corresponding text spans. This formed a hyperlink, bridging the text with its associated image, object, or region. The experiments with KOSMOS 2 yielded impressive results. It excelled not only in language and vision language tasks like KOSMOS 1, but also showed exceptional performance in grounding tasks. These tasks included understanding and generating referring expressions. In essence, this breakthrough feature of Microsoft's KOSMOS 2 can be used for numerous applications, like generating captions for images rooted in the visual context or answering queries based on a grounded understanding of visuals. Let's imagine this as a fun cooking recipe, but instead of ingredients and steps, we have images and text. So, Microsoft researchers whipped up a delicious dish they called Grit, a large-scale collection of grounded image text pairs. This is like the secret sauce that makes KOSMOS 2 so special. How did they make this sauce? They started with a hearty base of image text pairs from two sizable datasets, Koyo 700M and Lion 2B. Then, they mixed in a dash of innovation to extract and connect specific pieces of text from image captions to the objects they represent in the images. Let's peek at their recipe book. Step 1. Mix noun chunks with bounding boxes. Just like you'd separate eggs for a cake, they separated noun chunks from the image captions. Now, noun chunks aren't lumpy bits, but phrases with a noun and its associated description like a red apple. Think of a picture with a caption like a cat sleeping on a mat. Using a tool called Spacey, they would pick out the noun chunks, a cat, a mat. To make the recipe cleaner, they got rid of any hard-to-see flavors, like abstract noun phrases such as peace or freedom. Next, they took these noun chunks in the image and fed it into a pre-trained model. Think of it like a high-tech blender to draw bounding boxes or highlight regions linked to each noun chunk. Just like removing extra foam off the top, they discarded any bounding boxes that overlap too much using a technique called non-maximum suppression. Step 2. Bake in referring expressions. But they didn't stop there. To add more flavor, they they transform these noun chunks into referring expressions that provide more detailed descriptions of objects. Let's say we have a cat from our previous example. Using spaCy again to check the sentence's dependency structure, they would expand it to a cat sleeping on a mat, adding more details to our initial noun chunk. And just like in baking, we don't want our flavors to clash, so they only kept referring expressions that weren't already included in others. For example, if they have a cat sleeping on a mat, they wouldn't keep a mat because it's part of the first expression. Finally, they had their perfect grit sauce with a whopping 91 million images, 115 million text bands, and 137 million bounding boxes. They taste-tested grit by comparing it with other visual grounding datasets to see how well it performed. So, by creating grit, Microsoft has crafted a crucial ingredient to train AI models like KOSMOS 2, enhancing the AI's ability to link text with the images they represent, giving it an almost human-like ability to see and understand the world around us. How is KOSMOS 2 different from KOSMOS 1? Well, while KOSMOS 2 shares the same basic model architecture and training objective as KOSMOS 1, there's one key difference: the use of grounded image text pairs in its training data. What are grounded image text pairs? These are pairs that have text descriptions, like noun phrases or referring expressions that are directly linked to certain parts of an image. So this new type of training data gives KOSMOS 2 the extra superpowers of grounding and referring we've been talking about. And what about the ethical considerations? In the ethics statement of their paper, the team at Microsoft made it very clear that KOSMOS 2 has been developed strictly for academic and research purposes. They've categorically stated that it should not be used for generating inappropriate content, and any misuse of the model falls on the shoulders of those who misuse it. All of the model's development aligns with Microsoft's AI principles. So, to wrap it up, KOSMOS 2 is a cutting-edge multimodal large language model that's able to ground its understanding in the visual world. This is achieved by enhancing the multimodal corpora used in KOSMOS 1 with GRIT, their large-scale dataset of grounded image text pairs. The real magic of the model lies in its ability to perceive image regions and ground text output to the visual world, paving the way for numerous applications of multimodal large language models. Well folks, these in-depth explorations take a lot of research and hard work, so if you found this video helpful, please give it a big thumbs up, share it with your friends, and don't forget to hit the subscribe button to stay updated with our latest content. Also, click on the bell icon so you won't miss out on any of our upcoming deep dives into the fascinating world of AI. Thanks for watching the AI Trend. We'll see you in the next video.